Welcome back. In the last class we had seen some examples and then we understood the procedure to solve op-amp problems. If op-amp is in open loop, treat it as comparator. If op-amp is in negative feedback, apply nodal analysis because virtual current concept is valid. And if op-amp is in positive feedback, virtual current concept is not valid, then we have to treat it as a comparator, right? And then we had seen 4 examples: inverting amplifier, non-inverting amplifier, subtractor, and an adder. Now let's go for workbook problems. Okay. You know, when I was in engineering, I used to sit exactly in front of the class, and I was very much eager to rub the board. If my lecturer used to ask, Chakravarthy, can you clean the board? Then I was very much happy to clean the board. But now, whether I'm interested or not interested, I need to rub the board but it is multiple times. If you do it multiple times, the interest will go down. Yes, I'm interested to rub the board to explain. That is secondary, but what it may be. Okay, now, what is the session now? The session is for classroom workbook problems. Classroom workbook problems. The theory associated to all op-amp problems we can combine along with classroom workbook problems. Okay. Now write down problem number 1. What is problem number 1? Just a minute. Now try to read the problem. Now problem number 1. If the op-amp in the figure is ideal, the output voltage Vout will be equal to, right? Circuit is this is 8 kilo ohm, 1 kilo ohm, this is 2 volt, 3 volt, This is 5 kilo ohm. 1k, 1k. Okay. Asking for V0. Option A 1 volt, option B 6 volt, option C 14 volt, option D 17 volt. Okay. You solve. I'll give you 10 seconds. Try to. Now, according to our procedure, is it negative feedback problem or positive feedback problem? Negative feedback problem. Then apply virtual current concept. Because we don't know the voltages, you call it as VA, VA, your own wish. VX, VX, VY, VY, VZ, VZ, V1, V1, your wish. VA, VA, apply nodal analysis here, apply nodal analysis here, try to solve, you'll get the answer. I'm giving you 30 seconds, try to solve. Over? Okay, let's see. Negative feedback, therefore, this is VA, VA, right? Now, apply nodal analysis. VA minus 3 divided by 1k plus VA minus 0 divided by 8k is equal to 0. Kk will be cancelled. Multiply with 8. Then 8 VA minus 24 plus 8 is cancelled. VA is equal to 0. Then tell me it is nothing but 9 VA is equal to 24. VA is equal to 24 by 9. You can call this as equation 1. Okay. 2, 3, 1k, 1k, 8k, 5k. Okay, done. Now apply nodal analysis here at the other node. VA minus 2 divided by 1k plus VA minus V0 divided by 5k is equal to 0. Kk will be cancelled. Multiply with 5. Then 5 VA minus 10 plus VA is equal to V0. Therefore, V0 is equal to 6 VA minus 10. 6 into what is VA? 24 by 9 minus 10. Therefore, can I say 3 2s are 3 3s are, okay, 2 by 3, 3 8, 8 2s are 16, 16 minus 10, you will get 6 volt. You should get 6 volt. Okay, is the answer there? Yes, option B. Answer is B. Answer B. Now, second problem. The people who have solved this, you can go for second problem. Okay. This is GATE 2003. The problem is GATE 2003. Now, second problem, GATE 2007. Okay. Problem number 2. For the op-amp circuit shown in figure V0, the circuit is 1K, 1K, 1K and 1 volt. Okay. Negative feedback or positive feedback? Negative feedback, right? Because output is sampled and then fed back at negative terminal. Then watch organ concept is valid? Yes. You may think that all problems are easy, right? We will see as we go on. Everything I will not explain at the same time. Let me bias you that, yes, if the problem is related to negative feedback and then straightforward, we can go ahead straightforward. But as we go on, we will see one by one. Now, nodal analysis, apply nodal analysis at this point. Now, tell me VA minus 1 divided by 1K plus VA minus 0 divided by 1K plus current entering into op amp 0. 1K will be cancelled. 2 VA is equal to 1. VA is equal to 1 by 2. Equation number 1. Now apply nodal analysis at the other node. VA minus 1 divided by 1K plus VA minus V0 divided by 2K is equal to 0. KK will be cancelled. Then multiply with the 2. Then 2 VA minus 2 plus VA is equal to V0. Then what is V0? Therefore, V0 is equal to 3 into VA minus 2. What is 3? What is VA? VA is 1 by 2 from equation 1. Minus 2. 3 by 2 is 1.5 minus 2. Therefore, minus 0.5 volt. That is the answer. Therefore, what is V0? V0 is minus 0.5 volt. Answer is C. Therefore, answer for the second bit, answer C. This is better. In the meantime, when you write, I can rub it. Then we can see the problem. After that, problem number 3. Over. Okay. Problem number 3. In the circuit shown below, the op amps are ideal. Then V out. Okay. Problem is asking for V0. A4, B6, C8, D 10 volts. Done? Negative feedback or positive feedback? Both are in negative feedback only. This is also negative feedback. This is also negative feedback. Okay. Therefore, virtual ground concept is valid. What is the voltage at this point? Let us say this is VA. And what is the voltage at this point? This is VA. And let me call this voltage as V01, the output voltage of first stage. Okay. Let us say this is V01 and this is also V01 because virtual ground concept. Then apply nodal analysis. I think 3 times we need to apply. No need to apply. Yes, 2 times only if you apply enough. Tell me what is VA? No need to apply. Actually, what is VA? I didn't see that. VA, right? What is the current entering into op amp? The current entering into op amp is 0. If current entering into op amp is 0, then there is no drop across 1K. Then whatever 1 volt which is what is there, that will come here. Therefore, this is 1 volt. Then this is also 1 volt. Now we can apply nodal analysis at this node. Then you will get V01. Then apply nodal analysis at this node. You will get V0. Problem is over. Okay. Now let's see. Apply nodal analysis at this node. 1 minus of minus 2. 1 minus of minus 2 divided by 1K plus 1 minus V01 divided by 1K plus current entering into op amp, that is 0. Therefore, current leaving from this node plus current leaving from this node plus current leaving from this node. Therefore, 1K will be cancelled. This is nothing but 3 plus 1 is equal to V01. Right? Therefore, what is V01? V01 is equal to 4 volt. You can take it as equation 1. Now apply nodal analysis at the other node. This is V01. Therefore, what is V01 for? You can substitute later. V01 minus 0, V01 minus 0 divided by 1K plus V01 minus V0, V01 minus V0 divided by 1K plus current entering into op amp is equal to 0. Therefore, is equal to 0. 1K, 1K will be cancelled. Then what is our V0? V0 is equal to 2 into V01. Then what is V01? 4. Therefore, it is 8 volts. Therefore, what is the answer? Eight. C. Option C. Answer is C. If this is over, then fourth problem. Now from now onwards, slowly the difficulty or the difficult part of the problems will come. I'll give you 10 seconds. Then we'll see problem number 4. Over. Now write down, in the circuit shown below, the op amp is ideal. The transistor has VBE is equal to 0.6 and beta is equal to 150. Okay. Decide whether the feedback in the circuit is positive or negative and determine the voltage V at the output of op amp. Okay. The circuit is given and asking for the voltage V at the output of op amp after finding the type of feedback. Then option A positive feedback, option B positive feedback, option C negative feedback, option D negative feedback. Therefore, all options are given. Therefore, let's see the circuit. What is the circuit? This is what we need to find, V. Actually, this is a regulator. I'll explain that later. Okay, this is what is given. Now, we need to calculate V. After finding, VB is also given. VB is equal to 0.7 given VB not 0.7, 0.6 and beta 150. Then asking for the voltage V and type of feedback. Okay. Anyway, whether the problem is asking for the type of feedback, now our aim is to find the type of feedback, then only whether we can go for virtual ground concept or not. Only when op amp is a negative feedback, then only virtual ground concept is valid. Else, it is acting as a comparator. Okay. If op amp is in positive feedback, then it will be acting as a comparator. We should not use virtual ground concept. Remember, I am just stressing the point, the same point again and again. Now, let me tell you the technique to find the type of feedback. Okay, till now no need to find the type of feedback because directly we are able to see the type of feedback because output is sampled and then fed back at negative terminal, negative feedback, negative feedback. But here it is not straightforward. You may say output, it is not output. Where is output? First of all, we don't know, right? What it may be, something is sampled and then fed back at positive terminal. Therefore you say positive feedback? No, we cannot say like that. Okay, there is a technique. Let's see. Maybe few people are saying that positive feedback, right? And then what is V? V is nothing but positive feedback, and V is 10 volts, highest power supply. Let's see. Okay. This is a regulator circuit. Okay. Now, technique to find the type of feedback, right? Technique to find the type of feedback is open the loop. The technique to find the type of feedback is open the loop. You can open the loop anywhere, right? Don't disturb the original circuit. You draw once again and then try to explain on your own, right? I'm just using the original circuit only because if I want I can restore. Now, open the loop. Let me open the loop here. I can open anywhere, but let me open the loop here. Remember, this is the technique to find the type of feedback. When you open the loop, okay, then let us increase the voltage or decrease anything. Let us increase the voltage at this terminal. Then whatever you want you do, and then come back to this terminal. Then look whether if it is increasing, then positive feedback. If it is opposite, negative feedback. Why? In a loop, if something is increasing, negative feedback will make it constant. Positive feedback, if something is increasing, positive feedback will make it increment and then finally unstable output. What it may be, or saturated output. Now, in the case of negative feedback, let us say this is increasing. Now, let's come back to see what is the change here. If this is also increasing, positive feedback. If this is decreasing, negative feedback. This is the technique. Okay. Now, let's see. This is nothing but what? This is your collector, right? And this is emitter, this is base. Now when you increase the voltage at base, your base current will increase. When VBG will increase, base current will increase, collector current will increase, the drop across. Because what is this current? This is nothing but collector current only. Why? The current which is entering into op amp is 0. There is no current entering into op amp because input impedance of op amp is infinity, right? Therefore, whatever current which is what is flowing through 5K, the same current is flowing through your transistor. Therefore, if VB is increasing, VBG is increasing, IB is increasing, IC is increasing, drop across 5K is increasing, voltage at this node is decreasing. Voltage at this node is decreasing. When voltage at this node is decreasing, voltage at plus is decreasing. What is voltage at minus? 5 volt. That is constant. When voltage at plus is decreasing, then what is output? Your output also will decrease. Your output also will decrease. Therefore, is it in opposite sign? Yes, because it is in opposite sign, this is what is in negative feedback. I hope everyone understood. Therefore, this is in negative feedback. Not only that, I can open somewhere. You draw once again. This is a circuit and one more circuit to find. Wherever you have the loop, where in that loop the feedback should be there. Now what I do, let me open the loop here. This is 1.4K, 5K and 10 volts. Okay, you can open anywhere, right? Now this is plus, minus, okay, this is 5 volt. Now listen, if I open the loop here and then let us say, let us increase. Now when you increase this, voltage at plus is increasing, but the voltage at negative, that is constant. Then when plus is increasing, this voltage will increase. When this voltage is increasing, voltage at base will increase. When voltage at base is increasing, VBG will increase. When VBG is increasing, your IC will increase. When IC is increasing, the drop across 5K increases. When the drop across 5K is increasing, the voltage at this node will decrease. because this voltage is equal to this voltage plus the voltage at this point. I am saying about the node voltage with respect to ground. Therefore, that is decreasing. Is it in opposite direction? Yes. Therefore, negative feedback. Did you understand the technique? Therefore, from this also, wherever you have the loop, remember, you can say, you can open the loop and then change, then you come back. If the change is opposite, negative feedback. If the change is in the same direction, then positive feedback. Okay? Therefore, one part is over, finding the feedback. Now we got to know that it is in negative feedback. If op-amp is in negative feedback or the loop is in negative feedback, then immediately we can use virtual ground concept. Then if you use virtual ground concept, whatever voltage you have here, 5 volt, it is already battery. Then the other voltage is also 5 volt, that is also 5 volt. Then we can calculate the current through it. The same current is flowing through IC. Then we can calculate V, apply KVL, you'll get the answer. Simple, straightforward. At least try to solve the second one, finding the voltage at the output. Before that, you try to draw these two and then go back to the original circuit, then try to find V after applying virtual ground concept. Now we can use virtual ground concept because op-amp is in negative feedback. I hope this is clear. Okay, take it. Over? Did anyone find the answer? Okay, now if I go back to the problem, right? Therefore, if I go back, now this is what is your output which we need to find. Original problem. This is what we need to find V. Okay, and this is the collector. Now, what is V? Can I say this is nothing but V? This is nothing but V, because voltage at this point with respect to ground, right? That is what is V. Now apply KVL. Then if you apply KVL, V is equal to VBE. This is nothing but VBE plus the current. This is nothing but IE, and this is IC. IC is approximately equal to IE. Why? Beta is 150. Then you can say IE is approximately equal to IC. Then tell me what is your KVL. If you take KVL, then what is V? V is equal to VBE plus IE into 1.4K. Therefore, VBE, I can say, what is VBE? He has given. Given VBE is equal to 0.6. 0.6 plus IE is nothing but IC into 1.4K. If you know IC, problem is over. To find IC, right? What is IC? Now we can apply virtual current concept. When apply virtual current concept, what is this voltage? 5. Then what is this voltage? This is also 5. Means basically this is 5. When this is 5, we can find this current, right? This is nothing but IC, because the same current is flowing. The current entering into op amp is 0. Therefore, the current is 0 ampere. Therefore, tell me what is your IC now? IC is equal to 10 minus 5 divided by 5K. Then what is this? 1 milliampere. Then you substitute, then equation 1 implies what is V? V is equal to 0.6 plus 1 milli into 1.4. Therefore 1.4. Then V is equal to 2 volts. What is the answer? Negative feedback and 2 volts. Answer is D. Answer is D. Everybody understood? Just I'll give you 1 minute time. Then we'll see problem number 5. Done? Now problem number 5. The input resistance Ri of the amplifier shown in figure is, okay, circuit is given. Circuit is Ri. What is Ri? Option A 30 by 4 kilo ohm. Option B 10 kilo ohm. Option C 40 kilo ohm. Option D infinity. Okay. Just try to think for 2 seconds. Sorry, 10 seconds. Then we will see that. Okay, now qualitatively we can say the answer. If you have any doubt, we can solve that also. Okay, what do you mean by input impedance definition? Right, the impedance seen from input port. Right, maybe I can explain in a different way. First let me explain and come back to the qualitative part, then you'll understand. Now this is black box for you. Can I treat this as black box? If I treat this as black box, then it is defined with input port. Then let us say Vs is applied, right? This is what your Vs, this is your Vs. Now we want to know what is the input impedance seen. What do you want to find? Ri. Okay. What is Ri? According to the definition, some block. This is some block or some circuit. Therefore, what is Ri? Ri is nothing but whatever voltage you have. Let us say the current is what is entering into your amplifier is I1. Then the voltage what? Therefore, we are applying the voltage Vs. Therefore, Ri is nothing but Vs divided by current I1. This is what is nothing but your input impedance. That is what we did, right? When you apply the voltage, when you get some current, voltage by current is nothing but your input impedance. That is the definition, right? Therefore, there is a port with respect to ground. Apply voltage, get the current. Voltage by current is nothing but your input impedance, right? Now, if that is what is the case, that is input impedance. Remember, because it is forward direction. Output impedance, there is a reverse direction. Therefore, that is different. Therefore, this is input impedance. Now, Vs, okay. If you know I1, problem is over. Okay, how to find I1? That we can find, right? I1. How will you find I1? I1 is nothing but what? The current which is what is entering into this node. Therefore now, first of all, is this in negative feedback? Yes, negative feedback. Virtual current concept is valid? Yes, valid. Therefore, can I say this is 0? Yes, 0. But I want to find I1. Therefore, let us say this is what is the current which is what is entering. Let us say I1. How will you find I1? This voltage minus this voltage divided by 10K. Right? Therefore, I1 is equal to the voltage at this node is nothing but Vs, and voltage at this node is nothing but 0 divided by 10K. Right? Therefore, this is what is this? Then this is nothing but Vs divided by 10K. Then tell me what is Ri? Therefore, Ri is nothing but Vs by I1. What is Vs by I1? Vs by I1 is equal to 10 kilo ohm. Therefore, what is Ri? 10 kilo ohm. Answer is B. Qualitatively, I can explain. Impedance seen from this port with respect to ground. This is 0. Virtually connected to ground. Only 10K is present. Therefore, you get 10K only. That's it. Therefore, don't say 10K parallel to this and all. Not required. Enough. Straightforward. Because according to virtual ground concept, this is also 0. Then 10K input port impedance. Therefore, impedance seen from this port with respect to ground means with respect to 0 is 10K only. Or with respect to this also, Ri is equal to voltage by current. That is also the definition. I think almost the session is over. We don't have time and we have only 1 minute time. Then if you want, you can pause the video and then take the solution, or if you understand the solution, you can take it as granted. Okay, we'll meet in the next session. Thank you.